Let me know if my screen is visible. Type yes in the chat box. Okay, Madhu. Okay, let's start today's class. Let us do a small recap about the yesterday's class. Yesterday we have just developed our first Spring application. So usually when we use the Maven project to develop the Spring application, because Maven project is a management tool, right? That will help us to add dependencies and create documentations and to build projects. The latest version of Maven is 3, right? If you want to develop any Spring modules, you can make use of Maven project, because Maven project will organize all the dependencies in such a way that the things are going to be very easy for you to concentrate only on the developing part, not on how to manage dependencies. Right? These things will be taken care by Maven itself. Right? And again, if you open a Maven project, the Maven will expect you to give three kinds of inputs: group ID, artifact ID, and the version. So group ID is just like the company name. Artifact ID is going to be your project name, and the versioning. By default, the versioning is available to you by default, right? And again, this is your responsibility. If you want to develop a standalone application, make sure that you are choosing this archetype Maven archetype quick start, which is under org.apache, right? There are three subcategories, and you need to specifically choose org.apache. By selecting this, choose the new Maven project, and this is how you share the inputs: company name, project name, and the version, right? So this group ID talks about company name, artifact ID can talk about project name, sometimes jar file name, sometimes plugin names. The versioning also does the same thing. There are three kinds of specificities that you can choose on versioning. Apart from this, there are more than 2000 archetypes. So for the first application development, we have chosen quick start. If you want to develop an application, let us say a web application, you have to choose the web app archetype, right? So after this, then this is how the project folder, the structure of the project directory will be created by the Maven itself, right? And I have also mentioned some categories about the source folder and about the test folder, and, some Maven dependencies that will be placed by Maven itself, and some folders that is meant for Maven inputs, SORC and target. And we have a pom.xml file, project object model, where you will be placing all the dependencies. Right? If you want to change the Java version, you can change the Java version by just giving the version name. Maven will take care of giving you that version, particular Java version. You can work with any Java version, but I have chosen 16. Right? You can choose according to your necessity. And after this, I have chosen the Spring module dependency, which is placed inside MVN repository. You can get these things from the internet. Just type MVN repository and get the following dependency tab. So you will have to type Spring context support. To type Spring context support, you will get all the version. And I have chosen a version. I have chosen the 5.x version. Right? So after choosing this version, after adding this dependency in pom.xml file, after saving and refreshing the Maven, building the Maven, you will get all the dependent jars added to you. Added to your project folder. So all these dependency jars will be added to your project folder. And after adding those dependency jars, we have just started developing our application. So let me open Eclipse. So in my Eclipse, so I have chosen 3 packages. One package is meant for client application. Client application is very simple. Where when you want to where you want to start running your application, the main method, a particular package where you will place the main method is going to be what is going to be the main class or the client application. Any file where you will place the main method, that file is going to be what? That file is going to be what? The client application or the main class application. And this is the simple Java file that I have taken for the testing purpose. So a simple Java class, name of the class is allowbean. Inside this class, a typical method. This method, when I execute this method, it is going to return allow spring team. So, and I have also taken an XML file here. So this XML file, you do not have to learn about the XML configuration. All you have to do is, for the time being, you want to place an ID. If you are placing an ID, this ID is talking about the reference variable of an object. So usually we create object with the help of new keyword, and we give a reference name for that object, isn't it? So that reference name is going to be the reference name that is taken by this ID. ID means the reference variable name. You can give any name, any meaningful name, right? And yet class, the class which the name of the class, the fully qualified name of the class, you need to place here the fully qualified name of the class. If you are placing a particular class here, this class is going to act as a Spring Bean class. What does it really mean? To take this class, I am going to convert this class as Spring Bean class, which means I am giving the responsibility for object creation, object management, and the object deletion to the Spring framework. I am telling the Spring framework to create object, to manage object, and to destroy object. And I am also saying that me as a developer, I am not going to create an object with a new keyword, because if I create an object with a new keyword, that is enabling the tight coupling. So I want to achieve loose coupling. In order to achieve loose coupling, me as a developer, I should not be writing a code or creating object with a new keyword. So I'm giving this responsibility to the Spring containers. How Spring containers identifies our request? It will identify our request in this application context as XML file. Over here, I have passed the instruction saying that, hey Spring Bean, please create object for this particular class. The class that I am giving here is going to be, it is going to be known as a Spring Bean class, which means the object will be created by the bean container itself, right? And this is the pom.xml file. So we have seen this file yesterday. So it is used to add dependencies. So this is a typical dependencies that we have added. After adding these dependencies, we have got all these jars. This jars has been added by the Maven itself. So you, as a developer, you did not do anything to add this. You have just included this dependency section in the pom.xml file. As simple as that. Right? Let us run this application. See, if I run this application directly, so to run this application, I need to choose what? I need to go back to the main method. So this is the main method. So the main method is placed inside this package, balu.spring1. Inside this package, I have placed the main method. This is the main method, right? So let us say that if I am running this application by creating a new keyword. So what happens if I do new keyword? Hello bean object equal to new hello bean. So I am creating object explicitly by using new keyword. I am creating object for this class. So this is the hello bean class. So I am creating object explicitly. I am not supposed to create object, but I am telling you what happens if I create the object. So object has been created. So because of this line, the app class, see the app class is the class that I am talking here. The app class and the allow bean class gets tightly coupled in nature. Tightly coupled in nature. And system.out.println, I'm calling a method inside this class. Check.al. So I'm getting the output, but this is not the solution. I can get the output just by creating object explicitly by using the new keyword. Even I can get the output by using this approach, but this is not the expected approach. This is not why we are using Spring Framework. So we are using Spring Framework to make sure that the framework is creating object for this. The framework is creating object for us. We can achieve loose coupling. Now it is tightly coupled in nature. In order to achieve loose coupling, so we are requesting the framework to create object. Now with this approach, what is happening internally, I will explain you so that understanding the next part is going to be very easy. So let me open a new paint box. So approach one. An object is created by the developer. What exactly happens when an object is created by the developer? Just assume that this is the source file. So in this case, we have how many source files? We have app.java. This is one source file. We have allowbean.java. This is another source file. All the files with the .java extension. All the files with .java extensions, we call them as source files. So in this case, I have two source files. One is allowbean.java. Second one is what? App.java. So these are the two source files that I have developed. Source files. So what happens as soon as we start running, we start hitting the run command. So in this case, the run command is this is where the run command is. As soon as I start hitting this run up button. I'm getting the program is getting executed and the output is displayed in the console. But internally, so many things are happening. What are the things that are happening internally? That things we are going to understand now. So firstly, compiler will come into picture. So compiler will compile all the source files. How many source files are here? We have two source files. One is allowbean.java. Second one is app.java. Compiler. So compiler will check if there are any errors, and it will convert all the source files into .class files. Now two .class files will be generated by the compiler. One is allowbean.class file, and the second .class file is app.class file. So two .class files are generated by the compiler. After compilation, JVM comes into picture. So this is the JVM, right? So what JVM does? JVM will take a .class file. Which .class file it will take? It will take the main .class file. What is the main .class file? This is the main .class file. The class file which has main method is called as main.class file, right? So this app.class file will be loaded inside the JVM. That is the rule. JVM takes only main.class file. Will take main.class file. So app.class file will be loaded inside the JVM. 1 minute. This will be loaded inside the JVM. So as soon as the app.class file will be loaded inside the JVM, the main thread will be created. Main thread will try to get access to the main method. Inside the main method, the first instruction is like what? First instruction is like it is encountering instruction allow bean obj equal to new allow bean. Right now, allow bean dot class file will be loaded dynamically because it has encountered this allow bean instruction. So this dot class file has to get loaded inside the JVM. So this dot class file will also get loaded inside the JVM. Allow bean dot class file. See, now you will understand about the dependency. See, JVM wants to load only app.class file, but this app, along with this app.class file, it is also expecting allow.class file to be loaded inside the JVM because there is a dependency. First instruction is allow bean obj equal to allow. It means allow.class file has to get loaded inside the JVM. So in order to achieve that dependency, this dot class file is loaded inside the JVM. And the second instruction is an object is created for allow bean class file, and the reference variable is obj, and the instruction, and we are trying to call the say allow method on top of this object reference. So the next process is an object gets created internally inside the JVM. An object will be created, and the reference variable of this object is obj. And on top of this object, we are calling a method. The name of the method is say allow method. Right? After calling the say allow method, the output is going to be what? Allow sprinting. Output. What is the output? Allow sprinting. So this particular example, this particular diagrammatic illustration is talking about the tight coupling. This is talking about what? Tight coupling. Why tight coupling? Because object is created by the developer itself, and JVM is expecting the main method, main dot class file to be loaded inside the JVM. But along with the main dot class file, right, there is a dependency. Dependency for what? Dependency for what? Allow bean dot class file, because the developer is trying to create an object with the help of new keyword. So this dot class file is also getting loaded inside because of the dependency, and the object is getting created inside the JVM. And on top of this object reference, we are calling a method called say allow method. So say allow method is part of allow bean, right? Part of allow bean. Say allow method is part of allow bean, and this is getting executed, and the output is like what? Allow sprinting. Right? This is the typical way of calling a method on a particular class by using the new keyword. But I do not want to use the keyword. Instead of JVM, I need to use Spring containers. What I need to do, instead of creating an object inside the JVM, I want to use Spring containers. We have already seen there are two types of Spring containers. One is Bean Factory container, and second one is application context container. Spring containers are classified into two types. One is Bean Factory container. Bean Factory. Second one is what? Application context. Right? When I use the Spring container, what happens? The Spring containers will be placed on top of the JVMs. For example, if I am trying to use Bean Factory container, this Bean Factory container will be placed on top of the JVM. Right? So the object will be created by the container itself. right? If I use application context container, and again this application context container will be placed on top of the JVM. Whatever the container that I am specifying, that container will be coming into the picture and it will be placed on top of the JVM, right? This application context container will be creating an object. Developer doesn't need to use any new keyword. The object creation, object management, and object restriction will be taken care by the container itself, and these containers will be placed on top of the JVM. How this will be placed on top of the JVM, that we will understand now. So if I use this code, this is the typical diagrammatic illustration that we are going to encounter just by using this code. You can give this code reference for this particular diagrammatic illustration. As simple as that. This code reference is meant for this diagrammatic illustration. New keyword, so JVM comes into picture. This is JVM, right? Without using new keyword, I want to involve Spring containers like Bean Factory and application context. Let me delete this. Instead of using new keyword, I need to use containers. I need to appoint containers so that containers will take responsibility of object creation to achieve loose coupling. We will understand more about loose coupling. For the time being, just understand that when you create object, you are making it as tight coupling, but when you allow containers to create object, you are making it as loose coupling. This understanding is enough for the time being. Going forward, after working on many programs, we will understand exactly what does the loose coupling mean. What is the requirement of containers? For the time being, if you create object, tight coupling. If container creates object, loose coupling. This understanding will be enough. Now approach 1 is completed. Let's talk about approach 2. So this is the approach that we are talking about. This is the only reason why we are learning Spring modules. Approach 2. Allowing object life cycle management by Spring containers. So I need to involve containers now. How do we involve containers? That is the question. So let me delete this. To involve a container, I need to specify this. See, I have already created an XML file. So XML file, these particular instructions are given in application context.xml file. I need to specify this path in the client application, in the main method. Somehow I need to pass instructions saying that there is an XML file. Inside this XML file, there are some instructions to create an object for a particular class, for a particular Java class. And the name of the Java class is given, right? And the object reference variable is also specified, right? I need to give this information in the main method. How the information can be given? That is the question, right? So go to the main method. So you can give the information like, so there is a class called file system resource equal to new file system. So now don't try to get confused. Now I am using Bean Factory container. There are two containers. So in this program I am going to use Bean Factory container. Again, what is a container? Containers is an internal software where it will take care of object creation, management, and restriction. So there are two containers in Java in the Spring core, in Spring framework. One is Bean Factory, second one is application context. So now we are discussing about Bean Factory container, the basic container. So basic container means these containers are going to do the basic operations. And if you talk about application context container, that is somewhat an advanced container. So it is not only it will not only do the object creation, it will do more than this, more than the Bean Factory container does. It is just like an advanced container. So now we are using Bean Factory container. So we are trying to import a class file system resource. Here we will specify the path. What path we have to specify here? Very simple. The application context.xml location. We need to give the location where the XML file is configured. where we have specified the object creation in the XML configuration, in the form of XML configuration. That path we need to give it absolute path. So if you go application.context, application context.xml is placed under this folder, this package com.balu.cfgs. Again, this com.balu.cfgs is placed under this folder src/main/java. So this complete absolute path I need to specify. So src main java com balu cfgs space application context.xml. Very simple, isn't it? Absolute path, complete path. Hope it is visible. So complete path of the application.context XML file. And you could be asking, you might be wondering why the name application context.xml. You can give any name, but it is highly recommended to give application context.xml. You can give any name, any name, but this is highly recommended. Application context.xml. Right? So this line is going to like specify about the location. This line is saying that it will locate and hold the Spring configuration file so we are specifying the location where the configuration or where the instructions are given in the XML file for the object creation. This is the first line. The second line is we need to create a container. So I said there are two containers. One is Bean Factory container. The second one is application context container. So now we are working on Bean Factory container. So we need to create an object for the Bean Factory container. So for that the instruction is very simple. XML Bean Factory new XML Bean Factory resources. So XML Bean Factory equal new XML Bean Factory. This instruction is going to talk about the container creation. Create the Spring container. What Spring container? Bean Factory container. Bean Factory container. So first instruction talks about the location, exact location. Second instruction talks about the container creation. In this container creation, it is accepting this location information, RES. Right? Because of these two instructions, so many things happens internally. What are the things that is going to happen internally? Same. The two source files will be there, right? So there are two .java files, and the compiler will come into picture. Right? So once the compiler is getting into picture, right, it is going to generate two .class files, right? And there will be JVM. Right? Now we are involving what? We are asking the container to perform the object creation. What container we are using here? Bean Factory container. So on top of this JVM, a Bean Factory container will be created. So this container name is what? The Bean Factory. We are involving a container which is a Bean Factory container. So this is JVM or JR. So this is compiler. So we have two .class files. One is app.java, two .java files, app.java, allow bean.java. So after compilation, two dot class files will be generated. App dot class hello bean dot class. Right. While execution, the main dot class, the class which has the main method will be loaded inside the JVM. So this class will be loaded inside what? It will be loaded inside the JVM. Right. The first instruction inside the JVM is very simple. Locating the XML file. The XML file will be located, and the second instruction is container is getting created. The container bean factory container is getting involved. So this is the bean factory container. Now this container will take responsibility of object creation. Right. So it is looking for the third instruction. So in this bean factory container, we have specified some information in this particular configuration file. What information we have specified here? If you see here, create an object for this particular class. Which class? Allow bean class. Now bean factory will take the responsibility of object creation. For which class? Allow bean class. The name of the class is what? Allow bean. What is the object reference? Allow bean is the object reference. Allow bean is the object reference. So this is the object reference. Right. Now the third line. So far this many things has happened inside the container. Container has been involved, and inside the container object has just been created on accordance with our instructions, because these are the instructions that is found inside the XML file. So we are giving two instructions: create object for this class, and the reference variable is allowed. So it is going to create object with the reference variable allowed. Next possible thing is we need to utilize the object reference, right? For that, again go back to the app.java. So factory dot get bean allow bean. So here I am giving an instruction. What instruction I am giving? I want to catch this object, catch this reference variable, allow bean. Allow bean is a reference variable. So this is the reference variable. I need to catch this reference variable. So this particular line is going to return an object. This particular line is going to return an object. So I'm trying to catch this object reference variable. Very simple, guys. This particular line is going to allow us to do what? Allow us to catch this reference variable, which is allow bean itself. It is returning an object. The object itself is what? Allow bean. So we are catching this reference variable inside this object. Then we are using catch object. I will explain you these instructions. See, so this particular line is going to allow us to catch the object. Here TCS catch the object reference variable. So we got control of this object. Allow bean. Allow bean is now under our control, and we are using that reference variable right? We are using that reference variable on top of this class. We are just doing the upcasting, and I was just doing the object upcasting because this allow bean is part of object class. We are converting this object class to allow bean class. This is the core Java concept, complete core Java concept. We are performing the upcasting. The variable that we are getting here is in the form of object class. We are trying to convert this object class to allow bean class. On top of allow bean class, we are calling say allow method. As simple as that. We are calling say allow method. Output is what? Allow spring bean. Allow spring bean. So this is the approach to so this is the approach to. So we have done some kind of we have followed some rules and instructions. The first instruction is this line is going to create the bean factory container. So the bean factory container is created, and we are passing the location. It has found the location. Inside the location, we have given some instructions, and according to our instructions, an object is created for allow bean class. The reference variable is allow bean. So this line is talking about, this line is trying to catch the created object allow bean. So the allow bean is catched in the form of object class itself, because the return type is object. But we need to convert this object type to our class type. Our class type is allow bean type. That's why I'm doing this upcasting. Conversion, internal conversion. Right? So this factory, this factory reference is going to return the allow bean object, which is in the form of object class. This needs to be converted to allow bean class. That's why I did this internal conversion. This is called as upcasting in Java. Right? And on top of this created reference variable catched object, I am calling our method, which is say allow method. Right? So this say allow method is going to return what? It is going to return the output allow spring bean. You see this output. Do we have any dependency on JVM to display this output? No. We have just created what? We have just created a container, bean factory container. This bean factory container is taking care of object creation, and it is displaying the output in the console. After the output is displayed inside the console, this bean factory is going to destroy this object. You as a developer, you do not have to worry about this object creation and object destruction. You are just specifying the instructions in the form of XML bean factory class, and these things are taken care by the container itself, and container is taking responsibility of object creation, object management, object destructions. So this is the one of the ways to achieve the loose coupling. So here the tight coupling is not involved. Here the project, the Spring container is taking care of object creation. That's why we are not going to talk about, or we are not going to consider this as a tight coupling thing. It is going to be loose coupling, because inside our main class we haven't created an object with the help of new keyword. Of course we have used new, but this is not part of the class. This is part of the like file system location and part of the bean factory container. Not directly, we have not made any dependency for this allow bean class. We have not involved this allow bean class directly inside here with the help of new keyword. We have used allow bean class, but there is no point of we haven't used new keyword anywhere. No tightly coupled dependency here. This is the one difference between, main difference between approach 2. You talk about approach 1, everything is getting created by the JVM, right? But if you talk about approach 2, there are so many changes on the way the object is getting created, especially this area. Here the object is getting created in the JVM itself. It's inside the JVM itself, the object is getting created. But here if you see, the object creation is taken care by the bean factory container. This is what a typical loose coupling application is. Why we need to go for the Spring framework is to achieve the loose coupling. Why loose coupling can, how loose coupling can be achieved with the help of Spring containers. As simple as that, right? So in future, we are going to develop a lot of applications on top of this particular framework by using the same dependencies. So we'll get clear picture. This is just a basic application where you have to understand the use of XML file, and where you need to understand the use of bean factory classes, especially this particular classes, XML bean factory class. So I know that you might be confused with these two instructions. Very simple. I have just done the upcasting. The object will be the reference variable is written in the form of object class. We are converting this object class to our bean class, and with this reference variable, we are calling our method. Upcasting. This is something very important to be understood in the core Java. So try to focus on what is upcasting in Java. You will get much clarity. So the same step, same procedure will be following in the future. So this is talking about. So again, there will be some set of questions where you will encounter in your interview. The question will be like difference between invasive and non-invasive framework. Invasive and non-invasive frameworks. So what is an invasive framework and what is a non-invasive framework, right? So we are learning about Spring. Spring is a part of invasive framework or non-invasive framework. This understanding is very, very important. So invasive frameworks are like very simple to understand. For example, frameworks. Here, the classes framework based application development are tightly coupled with framework APIs. That is, the classes or interfaces that you develop should must implement the framework based APIs. Interface or classes. Application developed by the programmer for certain framework should implement on the same framework. So the explanation is very simple. So if you encounter this question, invasive frameworks are like if you are developing any application by using a specific framework, you need to ensure that the classes or applications that you are going to develop should implement or extend the framework based APIs. So the typical example is what? Struts. Struts framework. Right? You cannot develop any class or any interface with help of by using Strut framework without any dependencies. If you are developing any classes or interfaces by using in the Struts framework, you need to ensure that you are implementing or extending to this Strut framework API. The implementation is mandatory. It is just like committing for the marriage. Right? When you say invasive framework, it means you are trying to develop an application that is getting tightly coupled with the particular framework. That frameworks are called as invasive framework. And where the Spring framework stands, Spring framework is categorized under non-invasive framework. Why learning this invasive and non-invasive framework is mandatory? So these are the typical interview questions that you're going to come across. Invasive frameworks are like, ensuring that your APIs or your classes should get or should extend or should implement the framework based classes and interfaces. Tight coupling, you cannot once you give commitment, you cannot switch your project to any other framework. As long as the project exists, you should be sticking to the same framework. It is like a giving commitment for the marriage, right? But non-invasive Spring is like a non-invasive framework, so it is completely opposite to this invasive framework. Non-invasive framework. So here the explanation is going to be very simple. Here loosely coupled. Framework based APIs. Tightly coupling means invasive, loosely coupled means non-invasive. It is not mandatory to implement or extend the framework based classes or interfaces. You can develop classes or interfaces through POJO or OG model. Examples: Spring, Hibernate, Spring Boot, etc. Why we are learning Spring Boot, Hibernate? I mean, if anyone is asking why one should go for Spring framework, this is the typical answer that you can get. Because Spring framework is a non-invasive framework. What is non-invasive framework? This is the typical answer. You can develop, you can program your classes or interfaces that is independent of framework-based APIs. Like you do not have to give any kind of commitment or any kind of dependency or any kind of any kind of implementation where the classes and interfaces that are developing should implement or should extend to the framework based APIs. That commitment, you can ensure that you are not giving that commitment. So in future, if you want to migrate your project from this framework to another framework, the migration is going to be easy. Why it is going to be easy? Because applications are developed in a loosely coupled way. You are going to use POJO model or POJ modeling development. So some of the examples are like Hibernate, Spring Boot. So that's why they are falling under non-invasive framework. So this is the clear understanding about invasive framework and non-invasive framework. You can expect this for your interview. Invasive framework and non-invasive framework. So today we have learned few things. What? Two approaches. Approach number one is a tightly coupled approach where you will not involve container. If you are involving a Spring container, you are going to achieve loose coupling. Why you are going to achieve loose coupling? object creation will be taken care by the Spring itself. So this is the procedure to achieve loose coupling. So in the main method, create the bean factory container, right? And please ensure that the object reference variable is created, typecasted, and with the help of typecasted reference variable, call the method. Right? You are not creating, you are not specifying, or you are not calling object with the help of new keyword. These things are taken care internal by the container itself. Right? After that, we have learned what is invasive framework and what are non-invasive framework. So this is the typical difference between the invasive and the non-invasive framework. To read this, we'll understand once again. Right? So tomorrow we are going to discuss what are the other ways of creating an object. So you might have come across this particular concept, especially this concept, loading dot class files to the JVM with the help of class.forName. So class.forName, we will give the dot class file information here. The information here. We'll understand about this more tomorrow. Class.forName method and new instance method. New instance method. Right? This is the core Java concept, but this understanding is mandatory to understand more about the Spring containers. So theoretically, by looking at the execution, we got to know what is a bean factory. But internally, how the bean factory is achieving loose coupling, that understanding will come after getting to know about the object creation with the help of new instance method. You might have heard this, class.forName and new instance method. So this class.forName is used to load the dot class files explicitly. So here, if you see in the approach, when the dot class files are loaded according to the instructions available in the main method. So first it take photos. First it will take app.class file. It will be loaded inside, since it is a main class. Then inside the main class, it has found an object creation for another class. So dynamically it is getting loaded. So instead of loading it dynamically, if you want to load it manually, or if you want to load it explicitly without the involvement of JVM, so this is the approach that you can follow. Based on this approach, right? If you understand this approach, internal understanding of this particular bean factory is going to become very easy. So I will give you this understanding. We will understand about this particular two approaches tomorrow. Okay. I'm stopping the recording. So this is the first application. Try to replicate this application from your end for the better understanding. And also tomorrow we'll also learn one more thing. We will learn about the dependencies, target class and the dependent class. So these are the two words that you will come across frequently. Target class second one is dependent class. So after understanding this, we will understand about setter injection, constructor injection. Then we will write some complicated logics to develop any application by using Spring modules. So this, after completing these things, the basics and the basic core modules concepts will be completed. You can almost answer most of the interview questions. That's it from my side for the day.